good morning, good afternoon, and good evening. On behalf of PioPetro and Military Research Hub, I'd like to welcome you all in our summer internship program. My name is Mayar Tare, a senior gas and petrochemicals engineering student, SPE Egypt Young Professionals member, and I'll be your moderator for today. So, before we start, please keep the chat box professional and ethical, and don't forget to drop your question in the Q&A section below. So, without further ado, let's welcome Dr. Mohamed Ghareeb, who will give us a session on artificial lift technology. Dr. Mohamed has PhD in petroleum production engineering with a specialty in artificial lift and production engineering and operation. He is currently a staff member of Future University and a head of Petroleum Technology Department of New Cairo Technological University. Meanwhile, he is a global technical director of Artificial Lift System for United Lift Technologies. Dr. Ghareeb is a technical and business professional with over 34 years experience in oil and gas industry, with long experience of business development, sales, marketing, operation, teaching and applications, engineering covering artificial lift design, operation, troubleshooting and optimization for major services companies like Lufkin, GE, Tundra Process Solutions, Weatherford, United Lift Technologies, and oil field operation for a major operator like Eni, Agiba, GPC. Dr. Mohamed Ghareeb field experience include the setup, installation, operation, and optimization of different forms of artificial lift system in Middle East, North Africa, Russia, Romania, Turkey, and Brunei. Over the past years, Dr. Mohamed also has played a major role in the practical training for the field staff and engineers in oil and gas production engineering and well operations for different major companies in the MENA region, USA, Canada, Romania, Turkey, and Far East. Dr. Mohamed was Society of Petroleum Engineering SPE Egyptian Section President Program and Membership Chairperson. Also, he is the Membership Chairperson and Direction of SPE International Artificial Lift and Gas Deliquification Technical Section. He published and presented over 55 technical papers. He chairs several technical sessions for local and international conferences and workshops. Currently, he is a committee member of ATCE 2020 and 2021, MEALF, and SPE Middle East Artificial Lift Conference. Dr. Mohamed Ghareeb is 2011 and 22 recipients of the SPE Regional Technical Award in Production and Operation. Thank you so much, Dr. Mohamed, for coming today, and the mic is yours.
Thank you, Mayar. Thank you. Thanks a lot. Assalamu alaikum. Good morning, good afternoon, good evening. And I'm glad to be with you today, for this is first session about one of the main important technology for oil and gas. It's an artificial lift. Artificial lift system is one of the major technology for oil and gas, while if you are reviewing the wells producing, even currently, you will find over 95%, maybe up to 98% of the wells are artificially lifted. Artificially lifted due to several reasons, we'll try just to see what's the reason behind that and why the artificial lift technology is important, I guess the majority of you, while you are working in any company, you will find one form of artificial lift, which we will cover in our coming session. I try to divide the session as simple as possible. I try to just give my lectures to be as simple as possible because I received several, messages from different of you, different student, different young engineer and so on. They not have any background about petroleum engineering and so on. They are very interesting to work in artificial lift. Even some of the fresh graduate engineer which already joined the major artificial lift company or operators, working in this area of artificial lift. We'll try to divide all the training to 4 sessions. Today is one, tomorrow is the second, and next week is the same, Monday and Thursday. It will be also another 2 sessions, We'll try to cover the major artificial lift system, and if there is a times, we can go to some more type of artificial lift system. Our agenda for the 4 days will be like that. We'll try today to give you some introduction, general overview about artificial lift, what type of artificial lift, what's important for artificial lift, what we mean by artificial lifts, why we use artificial lift. Is artificial lift using only for oil, or can be used for water, or for even gas? Currently, most of the unconventional gas wells is using artificial lift, is artificially producing, and then we can give you some general overview about gas lift, reciprocating second rod pumping system, electrical submersible pumping system, and progressive cavity pump. This is a main artificial lift we'll try to cover in the 4 lectures, and we'll try, if there is a time, we can go to jet pumping system and plunger lift. However, I'll try to be simple as much as we can. And this is the 4th session will be a foundation for you to be an artificial lift engineers, or artificial lift surface specialist and so on. If you will need some more, you can have little bits, just some more reading or something like that, and you will be familiar with all type of artificial lift. Today, just as I said, this will be agenda of our today. I'll give you general overview about artificial lift, a comparison of different type of artificial lift as a general comparison. How we select artificial lift, what the main criteria to select artificial lift, why you're found in the same country, maybe in the same field, you will have different type of artificial lift producing or the same wells, or just same characters of the wells and so on. After that, I will going to gas lift. Since the gas lift is one of the main important artificial lift, especially currently start to be booming in some area for unconventional and so on. I will give you some concept about gas lift equipment and valves, mechanism, like how to design on mandering spacing, just in very short and just in very simple way, Gas lift basic optimization. If there is a time, we'll cover the last 2 points. If there is no time, we can cover in Q&A and so on. Generally speaking, what is artificial lift? And why we need artificial lift? How the well is producing? Mainly, in order to understand how the well is producing, why we need artificial lift, how the artificial lift is working, we have to understand the well. How the flow is flow inside the well, how the flow is flow from bottom of the well to the top. What's making the flow to flow? Just in order for any flow just to flow from one point to the other point, then you need to have a delta P, differential pressures. In order to have a flow to flow from the reservoir going to the well, to inside the well, then you have to be, the reservoir pressures should be higher than the pressure inside the well against the formation, against the perforation, what we are calling here bottom hole flowing pressure. Then the bottom hole flowing pressure is the pressure at the bottom of the well, the pressure against the reservoir, while the well is producing, while the flow is flow. Then in order the flow to come from the reservoir and entering to the wells, then the reservoir pressures, P reservoir, must be higher than the bottom hole flow pressure. Okay, this 1 point. What else? What's making a flow to flow from the bottom of the well to the surface? In order the flow to flow from the bottom of the wells then to the surface, then the bottom hole flowing pressure should be high enough to overcome what? Should be high enough to overcome the P hydrostatic, the weight of the fluid inside the well. from the bottom of the well up to the surface. It is a hydrostatic pressure of the fluid inside the well, whatever type of fluid. Oil with water, oil with gas, oil with gas, whatever type of flow inside the wells. This is the hydrostatic pressure. Equivalent to that, bottom hole flowing pressure should be, lifting that, should be capable to lift that. Not only that, I need the flow to reach to the surface, not only to reach to the surface. I need the flow to reach to the surface with a certain wellhead pressure, what we call surface pressure. What is a surface pressure? The pressure is required to move the fluids from the well head up to the inside separator, to the surface facility, because I need just to treat this oil and so on. While the fluid is flow in the pipe and so there is a pressure loss. Then the pressure loss, this is added pressure to the pressure required to lifting. Then, in order for that wells to be a flowing well, naturally flowing wells, then the bottom hole flow pressure should be equal or higher than the hydrostatic head of the fluid inside the well, plus the wellhead pressure, plus the pressure loss. That's if I have a well in that situation, that means this well is naturally flowing, doesn't require any type of artificial lift. It's using the natural power of the pressure from the wells, and the well can produce natural. What happened, when we need artificial lifts for one well like that, for such well like that, we need artificial lift if this is higher or equal. Sample should be less samples, that mean when the bottom hole flowing pressure is less than the summation of the hydrostatic head plus the surface pressures plus the pressure loss, that means this will need some help, need something to help him, to lift the fluid, to generate pressures, to generate bottom hole artificially, bottom hole flowing pressure or artificial pressures downhole capable to overcome these three type of pressure. That's mean in this case we need an artificial lift system for the well. That's in the oil and gas industry, artificial lift, that's mean, or in this case, artificial lift is referred to any technique, any types you are employed or you are used in the wells just to generate different type of pressures. Remember, see here I put, the word is pressures, not pressure one, it's pressures, more than one pressure. That means the artificial lift is generated artificially more than one pressure inside the well port. What is pressures? What type of pressures? I will show you later on what this pressure, what type of pressures, why is more than one pressures is artificial lift need to generate it inside the well. Someone will say, okay, you said in the previous slides that say I need bottom hole flowing pressure to be higher than the hydrostatic head plus pressure losses plus the wellhead pressure. But what other pressure is here? I will show you what other pressures is here and so on. This is done either by, by just reduce one of the item like hydrostatic head. If I reduce the value of hydrostatic head or the wellhead pressures or the pressure loss, whatever is capable to give me the equations which is making the bottom hole flowing pressure capable to lift all that flow, it can be, artificial lifted or just can be the well, it's enhanced production or just reducing production. That's mean, I need just to initiating production from what type of wells? What type of wells artificial lift should be used? Either well is not produced at all, non-flowing, the fluid inside the well is not able to reach to the surface, that we call non-flowing wells, or well already flowing, but I use artificial lift for that wells. When I use artificial lift for a flowing wells, if this flowing wells producing less production than what I expected, according to the well productivity and productivity index or just well in flow performance, the well is capable to produce a certain flow rate, but the well only produce, just much less than that or less than this value of this flow rate. In this case, we are using artificial lift to enhance, to increase production from currently flowing wells, okay? If you look to this is graph, what showing inflow and outflow. That's mean well is not producing, outflow is not cut the inflow. The well is produced if the outflow is cut the inflow performance. This is inflow performance. This is outflow performance. This type of wells called dead wells. In this type of wells, we need to use an artificial lift in order just to move this is outflow curve down, to cut to intercept with this is inflow in order to give me certain production according to the reservoir requirement, reservoir engineering requirement. Or a well like this in the left side graph, it's already well produced. This is the outflow, it's intercept with the inflow cut, but at a certain flow rate. Still, if you look to the right side hand, still still we can produce more and more than what we are currently this well produced. In order to do that, we need to move this outflow curve to the right side. In order to move this curve to the right side, that's mean I need artificial lift. In both cases, I need artificial lift to just producing the well with a situation like the downhole, the down curve, the curve in the down of the screen, In this case, yes, I produce near to the open potentials. And this case, if you compare with the first one, the dead well, the well is produced. If you compare with the wells, flowing wells at a certain flow rate, yes, the well produced, but with a higher production rate, with a higher flow rate. In both cases, this is if you use artificial lift, is transfer your situation to the lower curve, lower part, inflow and outflow curve. That's mean what? For this case, for example, if I have a well producing with bottom hole flow pressures, BWF1 at flow rates Q1, in this case, the well still have potentials, to produce. If I run an artificial lift in this well, if I wanted to produce higher production in like a Q2, in this case, the bottom hole flow pressure will be lower than the well is produced. Lower bottom hole flow pressures, in that case, it's far from the outflow value need to lift the flow to the surface. In this case, what we need? We need to run an artificial lift to generate more delta P, more pressure. That's mean not only to generate bottom hole flow pressure, no, to generate bottom hole flow pressure, just to reduce the bottom hole flow pressure in order to allow the reservoir to give me more production. But if I reducing bottom hole flow pressure, that's mean it will not be capable to lift float. In the same way, or in the same times, the artificial lift should be generated some delta P pressure above the pump. Below the device, the pump, whatever system you use, below that, you are generated bottom hole flow pressure. You are reducing the bottom hole flow pressure. Reducing bottom hole flow pressure as a reservoir point of view, you allow more flow to come from reservoir. But in the same time, the amount of flow will be much less. Amount of pressures will be much less to lift flow. Then in this case, the artificial lift system must be generated another artificial pressures. What this artificial lift is called discharge pressures. The pressure required to lift flow to the surface with the wellhead pressures and overcome the discharge pressure. That means the artificial lift in any wells is generated two type of artificial pressures. Is generated artificially bottom hole flow pressure less than the normal, less than the current I used. In the same time, generated artificially discharge pressure, or just what we call here, artificially new bottom hole flow pressure above the pumps to lift the flow to the surface with the wellhead pressures capable to move the flow to the facility. Then how this come? Generally, this can be achieved by either used a pumping system inside the wells, device, whatever type of pumping system is making these two different pressure, one below the pump and one above the pump. The below the pump is called pump intake pressure. In this case, pressure, it's a pump intake pressure if the pump is sitting at the formations, depths, and so on, plus some discharge pressure above the pump. Then decreasing the pumping system, again, is decreasing the back pressure against the reservoir to produce the desired production, the required production. In the mean times, is creating, as I said, discharge pressure capable to lift the fluid to the surface. Or in the other side, I can, lightening the head or the fluid inside the wells. If I have inside the well oil or oil with water and so on, if I start to inject some light fluids or just like gas, injecting gas, the hydrostatic head, in this case, the average gradient of the fluid will be less. Then the hydrostatic head will be less. In this case, the bottom hole flow pressure will be capable to lift the fluid and so on to the surface. This is just, a graph, simple to show what I already explained before, about what we need from artificial lift as a pumping system or as an artificial lift system. This well is just died well or well not produced. Fluid reach up to a certain level inside the wells, and this is a curve represent the hydrostatic or gradients of the fluid inside the wells. If this is equivalent to the reservoir static pressures, based on reservoir static pressures and bottom hole static pressures, the fluid capable to reach to a certain level inside the well. If I want to produce this well, then I must have, if you remember the first slide, I must have a pressure inside the wells here should be less than the static reservoir pressure. In order to do that, I must have what we call the drawdown. Then, if I reduce the static reservoir pressure and the fluid going to the reservoir with a bottom hole flow pressure with a value less than the hydrostatic head pressure, then the fluid will reach to lower than the depth which we have lifted, or just the hydrostatic head is lifted. In this case, what happened? In this case, I need to run a pumps. The pump, what we call the pump, making me or just generated this drawdown. Since the pump is generated drawdown below this pump, in meanwhile, this pump should be generated another pressures, another discharge pressure is making another, what we call artificially pressure discharge pressure. Is taking the pressure below it and added some more extra pressures, what we call discharge pressure, pump discharge pressure above the pump, is capable to lift fluid to the surface with the wellhead pressures capable to lift fluid, just to move the fluid to the separator. This is if I use a pumping system. If I used an gas lift or whatever type of foam, whatever type of just something to reduce the hydrostatic head or the fluid gradient of the fluid, in this case, what we have in, you are reducing the hydrostatic head, and all the equivalent hydrostatic head will be less than the previous one. In this case, we are lifting flow to the surface with the equivalent wellhead pressures and so on. What's available in the market just making this type of artificially pressure inside the wells? In all cases, there is as I said, there is an artificial pressure inside the well. All the artificial lift system is doing is just generated artificially pressure inside the well. According to the current applications and current using worldwide or type of artificial lift, according to the energy source and so, they are divided to two categories. One is called formation pressure assist. Formation pressure assist, assisting the formation pressure. The formation pressure is less, I assisting that's the bottom hole flow pressures, which was give me, inside the well, and I reducing the hydrostatic head inside the well, or gas assist, or whatever we have, there is no pump using in this type of artificial lift is just formation of pressure assist or gas assist, whatever you have. Plus, there is plenty or just different type of what we call mechanical assist. Mechanical assist, in the mechanical assist, I have to run a mechanical device inside the wells, whatever type of mechanical. There is different technique, either electric, hydraulics, mechanics, whatever driven by watts. And this is just can give me, the target required from artificially pressure inside the well. For the formation assist or gas assist in the market currently, they are using what you call plunger lift, foam assist or foam lift, gas lift, and so on. Each one have a different categories, different applications, and so on. And for mechanical assist, we have rod lift, PCP, hydraulic lift. There is different type of hydraulic lift. The PCP is abbreviation for progressive cavity pumping system. Plus ESP is electrical submersible pumping system, and so on. Then, based on what we are mentioned before, what I need from the artificial lift, I run artificial lift inside the wells. In what type of artificial lift I must be used in order to decide what type of artificial lift I need to use, or I must be used, or suitable for my well. I have to know what I need from my artificial lift, what I want from this artificial lift system I have to run in the well. Remember, when we run artificial lift system in the well, usually most of the operators is desire or just prefer to run a system for the life of the well, because changing artificial lift, it's not an easy. It can be, but it's not preferred. It's not preferred. If you found the system can run from beginning up to the end, is okay. However, there is different type of reservoir, of wells, and so on, is required sometimes to change artificial lift during the life of the well. Then I need from artificial lift to maximize production. My main target is production, to maximize production. Meanwhile, to be flexible in production rate. Because remember, there is different type of reservoir, like water drive, gas drive, depletion drive, and so on. So production rates can be changed with time. Or even if the well under some enhanced oil recovery or secondary recovery, the production rate can be changed with time. Then I need type of artificial lift. If I run, I can easy to change the parameters to meet or just to cope with the well production rate change in production rate. Meanwhile, I don't need something expensive, because remember, when you put the well in artificial lift, that means each one barrel you are lifting, you pay against that a certain amount of dollars, certain amount of money. Then when you are reducing the lifting cost, you are getting more revenue from that wells. Then not only, just the cost here will be on the equipment cost or just the purchasing cost, what you call capital investment. No, even one of the main important investment, it's what you call operating cost. Sometimes the capital investment is higher, but the operating cost is less. With the times you found you have save a lot of money and so on. And also this should be reliable with uptime and so that's mean what type of failures we have. What's the time between failures? If there is a failure, yes, the system is cheap and the operating cost is low, but these wells from time to time is required some what you call some maintenance or just some repair, because there is a downhole failures for the equipment. Is this equipment failed each 3 months, each year, or each couple of years, and so on? Power consumptions, how much, especially in these days, the power consumption is very critical, especially in some area, remote area, while there is no power and you generated power by yourself, or just you are using power from the government grids or so on, And there is a lot of artificial lift system using, in some area, near to just people living in that area and so on, what type of noise and so on, And also sometimes, it's using in farm or using in offshore. Is this artificial lift need big footprint, big spacing to install or no? This is just a general view about when I start to decide what type of artificial lift I need, what type of system I have to run, even for the same system what type of size, what type of configuration, and so on. I have to put in mind something like that, what I have in present view. Then at the end, for artificial lift, I need to maximize my output for artificial lift system by ensure equipment that's equipment producing optimum. It's in optimum condition, optimum efficiency, optimum cost, optimum as a safety point of view, and so on. And this can be achieved by minimizing equipment downtimes. Is this equipment? It's what the downtimes per month, per day, per years, and so on. And also to reduce intervention frequency. Interventions that mean you are going to do a servicing for the rig, either rigless or just using a rig. And I have to minimize all that. From time to time, I should be not stick with my old technology, old technique, even for the same system. For example, if I use ESP system, and most times there is some new technology, new innovative technology, I can change, I can replace, I can add it, I can improve, and so on. There is a lot of technology, especially in the area of artificial, from time to time, it will be in the market. If there is a sand and there is a problem, and you found downhole bumps, downhole equipment, if there is a gas and some like that corrosion, and so on. That's mean artificial lift, it is a unique approach for the selection, in order to selection. That's mean, when I want to select the best type or the optimum type for my wells, I have to look to every aspects from the reservoir and the reservoir condition, the reservoir types, up to the end, up to the facility, while the flow reach to the facility. Because artificial lift is used to lift flow from the bottom of the well and moving it up to the facility. All that, I have to look all that facility. The well inside the wells, what type of wells, is a vertical wells, horizontal wells, deviated wells, and so on, Let us to go a little bit, quickly in some of that aspects, and consideration have to be considered. Like reservoir parameters, as I mean, pressures. Is the reservoir pressure is high or low? Is the reservoir pressure is depleted? Is the reservoir pressure is supported or not supported? What's the productivity index, PI? What's the water cut? Is the water cut will increase with time? Is this a reservoir is water drive, weak water drive, active water drive? What's the permeability? What is the flow efficiency inside the well? And so if there is a sand or tendency to produce a sand, if there is even for the water, sometimes initially there is very low water cut. With the time the water cut was increased, depend on how you're running your system, how you are depleted, downhole, how you generated the drawdown inside the well, the gas oil ratio or gas liquid ratio. Even we can have gas oil ratio for the gas inside the well, and outside, we can say gas oil ratio. So all that's, as a parameter I have to consider. I should be not ignored any one of that one. And also the well parameter, depths, shallow wells or deep wells. If deep wells, it's deviated wells or vertical wells. Even for deviated wells, what type of deviations, what's the duplex severity, how is deviated? What's the completion design? Sometimes I have to run a certain completion, due to a certain requirement for the wells, for some condition, and so on. What is the completion I have? Location, it is onshore or offshore, the wells, Cost, we like to look to the cost, especially operating cost. Capital, yes, but especially operating cost, because this is artificial lift running for the life of the wells, and usually, for the life, then I have to run for this one, reliability for the system. If the system reliable with me, the main important really factor is the local experience. Sometimes when we are going to some area, some fields, we found majority of the wells producing with a certain type of artificial lift. For example, I saw some companies near to each other, just there is a portal between the company. One use ESP, the other use road lift system. Why? Yes, both, because in this case, they found the both type of artificial lift can lifting the wells, can producing the wells with a good efficiency, with a good operating cost. But the operators have a good experience in some area. What is experience in this area? Someone have a very good experience in road lift systems, then he prefer to use road lift system because if something happened, what he knows the source. Some other he's preferred to use, for example, a ESP or PCP or and so on. And someone would like to standardize. Yes, and at initially life of the wells using maybe I don't know 40-50% of the well with a certain type of artificial lift. When start to drill more, then he doesn't like to change. He like to standardize type of artificial lift in order to standardize for the spare parts, for everything, and so on. This is, a table just summarize comparison with different type of artificial lift based on what we are mentioned before. This table, need to update really. Need to update now with the new technology because artificial lift really daily there is something new for each type of artificial lift. Based on the requirement, based on the technology, based on what we found in the markets, and so on. For example, if you look to the maximum operating depths. And what's the maximum operating depths for artificial lift? Someone will say, okay, for road lift 17,000, but it's not general 17,000. Yes, it can be run up to 17,000 feet, but in case the production is low. Usually the operating depths for artificial lift is jointly, we have to look in the same time to how much I need to produce from that well. For example, if you look to the second row, you'll find the maximum operating volume. For example, for PCP is 4,500 barrel per day. Now is more. Now with the new technology, we can produce more than that. You can go higher and higher than this one. But this cannot sometimes reach it to, cannot produce from a pump sitting at depths 12,000 feet or 13,000 feet. Then when the depth is increased, the amount of fluid capability to lift usually is decreased. Then I have to look to each one of these parameters in the table as a separate value. Not, for example, if we look back again to the first row, road lift system, cannot someone will say, okay, I can run to 17,000 feet and the table say I can produce 7,000 barrels per day. No. In this case, 17,000 feet, maybe you can produce only 50 barrel, 40 barrel, 30 barrel. But 7,000 feet, yes, it can produce, but at shallow depths, like a lot of wells in Canada, for example, now it's producing 7,000 or just a little bit more or less barrel per day from a depth of about 1,000 feet maximum, 1,200 feet maximum, and so on. If you go to the gas lift, yes, if there is a capability of gas and, the bottom hole flow pressure is a little bit good enough, and we have enough gas and so on, you can produce very high amount of volume. Same for the ESP. But, remember, even for the ESP, the depths also limited with that and so on. All the other parameters, if you look to here, sometimes you put the table in front of you, just a guideline. You take all that value and to use the value, you have to design, as a guideline. For example, if I say, okay, I want to produce from a well, for example, 4,000 barrel per day. Okay, 4,000 barrel per day. Yes, all the system can be capable to run except plunger lift. Then I excluded plunger lift. Yes, these wells, the bottom hole temperature is, for example, is high. The bottom hole temperature is around 500 degrees Fahrenheit. Yes, it's all is accepted except the BCB, except the, for example, that's mean, if you look to the table, this table just gives you a first guideline about what type of artificial lift I have to use, how to exclude a certain type from the other type. For example, if I have heavy crude oils, heavy crude oil, yes, I look to PCB or I look to what type of artificial lift and so on, This is just a guideline and in order to allow you, to start to select the most suitable, the economical ways, the artificial lift system. Okay, in this case, what is the challenge? In this case, not only, just if I look to the well to produce this type of fluid, this volume of fluid from that depth, and so on. Then I selected, no, there is some more challenge when you start, to hide, when you start to just to to compare some artificial lift for more than one problem inside the well, then you will find more challenging technique you have, to put into considerations just in order to produce a well, like difficult fluids, gas, specific gravity, viscosity, and so on, well condition, like deviations, like horizontal wells, like dogleg severity, location offshore, onshore, amount of production, all considerations, reservoir. At the end, all that's, come to the economical ways and so on. Okay, I just added for you some of the slides, just, about more of what we are mentioned before about what we need to consider when you are selecting an artificial lift system for your reference, when you are reading, and for the session of Q&A, if you want to ask me more and more, you can find. But I put this just to clarify, maybe, while I just explain, maybe I'm not clear enough for that, For example, for what mean of the reservoir and fluids, IPR, inflow performance, liquid production rate, and water cuts, and so on, gas liquid ratio, viscosity, what's formation volume factor. Remember, when you start to design artificial lift and when you start to use artificial lift, you are using artificial lift to displace fluids at the reservoir depths. That means the volume of the fluid, what the pump is displaced or just produced at the pump depth is completely different than what you are receiving in the tank. Then when you start to design, when you start to select the pump, when you start to calculate how much I need to produce at the surface, then you have to calculate the bottom hole displacement fluid. You have to consider what you call formation volume factor. You have to consider also reservoir driving mechanism. For example, what I say, the system flexibility for change in reservoir pressure and flow rates, and so on. Also, this is the reservoir characterization. What's the depth? What's the casing? What type of completion? Sometimes I am restricted to use a certain type of completion due to some downhole conditions, problems or downhole conditions. I have to produce from more than one zone, And for example, I use rod lift or I use PCP. And so how to produce from more than one zone, commingly, or just, separates each zone, at a single zone, and so on, this is casing and tubing, What size of casing? I use slim hole or just normal size of casing? Is this casing capable to run the tubing inside it? What's the smallest tubing I can use inside this well in order to produce the well? As I said, the whole deviation. For example, if I used reciprocating or PCP artificial lift with a deviation, have to be considered some more factors, some more, parameters. Special design downhole, yes, it can be used, but with a special design can be used downhole, and so on. Plus surface facility, surface production facility, how the flow rates, how much flow rates these production facilities can be handled, and the pressures, and how much, pressure loss can be handled due to the flow rates, contamination. If these fluids have some paraffins, some salt content, have some, sour gas, have some waters, saline waters, brine waters, what type of salinity, and sand, one of the major problems for all type of artificial lift is the sand and corrosions. This is really one of the major problems for us, that if there is a power available at the well site or just at the field, what power source? Is the power source enough to run the system? And so on, field locations, as I said, onshore, offshore, far away, or just in the middle of the desert, and so on, Operating, field operating characterization, Yes, this field is planned to have a big reservoir. There's a planned recovery for these wells to produce my field or my reservoir over 20 years, over 50 years, or over just a Lance's reservoir, small reservoir, what you call long ring recovery plan, Is there is a pressure maintenance inside that? All that, I don't need to ignore it, Someone, I saw some of the engineer who start to design artificial lift or select artificial lift, select based on the production, depths, and so on, and ignored, a lot of parameters. And after a couple of months, they start to face a big problem. If there is a field plan to have enhanced oil recovery after 5 years, 6 years, then I don't need to change my artificial lift. If I start to select artificial lift capable to produce a well with all the challenge I mentioned before and economicals and can be continue to use the same type of artificial lift after enhanced oil recovery, that will be a great, I see a lot of fields here, for example, in some Middle East using, for example, currently a steam injection or some other injection, and whatever use artificial lift from the beginning is still using the same for what type of automation? Is there automation technology available? Because currently with the using of all the technology like artificial intelligence and machine learning and so on, you can control the well from your mobile. If there is availability for that automation, monitoring the downhole, monitoring the surface, and diagnostic what problem they have, or this type of artificial lift have a limitation on that. There is no big, data or no big automation system. You can change parameter, you can change the well condition, and so on, And availability, as I mentioned in the couple of slides before, local experience, availability of the operating and service person, and to support the system and the area, and so on. This is just a general overview about artificial lift. This is really general about artificial lift. But give you some foundation about, if you start to hear about artificial lift, what I need to consider. If you start, to work in a company and put you on engineering to design, to select artificial lift, you have to put in mind, yes, artificial lift is a unique design. Artificial lift, yes, it's a very simple techniques, very simple what you call technologies and so on, but meanwhile is required to consider a lot of information, a lot of data. I need to consider everything because artificial lift is running 24 hours for the wells. Artificial lift is running continuously for each wells. Artificial lift is running even if the condition of the wells change, if the condition of the reservoir change, condition of the fluid producing from the well change. Artificial lift must withstand the well problems. I have a wells and wells is deviated or horizontal, wells have corrosions, they have some sand, and so how I use my artificial lift with a certain parameter selecting from beginning, just also to withstand all that type of condition. This just as a general about artificial lift and what type of artificial lift currently in the markets, what we have in the markets, and so on.
Thank
One
you.
of the
Thank
main
you so
point.
much.
No, you're good. If you wanted to continue, I can give you another 30 minutes if you like, or just more for other, or if you wanted to break now for some question, I'm ready, whatever you like.
We have two questions now.
Yes.
The first one asking if you want to gas lift an inactive well where the bottom hole pressure has been equalized to reservoir pressure. Is it going to be valuable? If yes, what will be the parameter to look for optimization?
Okay, this is, I cannot say yes or no, yes. Sometimes yes, sometimes no, depends on, as I said, if you back to the previous slide, what I said before, and also we plan to go to the gas lift. If you look to all the parameter, what type of load inside the well? What is the bottom hole pressures? If for example, if you inform me that I have well is did cease to flow and the fluid inside the wells, for example, the well depth 6,000 feet, the fluid inside the wells at 4,000 feet, the fluid API gravity is 20, 25 APIs, the reservoir gas oil ratio, it's 200, 300, 500, maybe I say no. But if you tell me, yes, I have a reservoir from 6,000 feet, the fluid inside the wells, just at maybe 200, 300, 500, 1,000 feet from the surface the API is over 30 or 35. The gas liquid ratio inside with this well, it's quite a little bit high and so on. Maybe yes, maybe I say yes, we can use. This depends on, in some parameter, we'll try to present it in gas lift and so on, because it's not an easy to say straightforward yes or no. If you look to all the previous slide, what I said, when I start to select or design artificial lift, I need to look to all different parameters can be affecting on the lift system. And I will plan just, after our gas lift, if it's not clear, we can answer again. Okay.
Okay, and the second question, is foam lift same like capillary string for gas well to deliquification method? Why are we using foam to lift well?
Yes, usually, foam, yes, you're right, usually we are using the foam lift for gas well deliquifications, You use foam for gas well deliquification, just, the foaming, reducing the hydrostatic head, Some gas wells have a tendency of what we call liquid, liquid hold up, liquid, just droplets due to some low reservoir pressures or low bottom hole flowing pressure. We use foam just like, like apparent gases inside the wells. The main important here just to reduce the hydrostatic head of the gas well. Sometimes, but not, not common used. We can use for shallow, wells with a very high gas ratio, oil, low production, could be, but generally speaking, it's usually used for gas wells, and it's not common use because it required a lot of foam. Required also, it's a little bit expensive, unless it's with economical study we found it can be used, for even for low production wells. It's not for high gas production wells and so on.
Okay, thank you, Dr. Mohamed.
Okay, I continue for gas lift or just you want to?
Okay, of course, you can continue.
Okay, thank you. Okay, let us just, walk you just through the gas lift, one of the main important artificial lift. While it's, it's really, it's more used for offshore wells, majority of offshore wells using gas lift or just sometime other ESP wells and so on. Currently in different area for unconventional gas wells using also gas lift and so on. However, let us just to have some quick overview about gas lift. I start with the gas lift as the first type of artificial lift for one reason, because, it is a lot of people consider this extending of the flowing wells. Whatever you are dealing with the flowing wells, you are understanding flowing wells, you can easy to understand the gas lift wells. The gas lift wells, we can consider, it is a flowing wells with some artificially gas injection, with some artificially reducing the hydrostatic head. If you remember, the first slide we say the bottom hole flow pressure here at the bottom of the well, it should be capable to lift the hydrostatic head plus the wellhead pressures plus the pressure loss. The hydrostatic head of the fluid is a function of what? Of the fluid gradient inside the well, and the fluid gradient inside the well is a function of the fluid density. Fluid density, if it's only water or just only oil or oil with gas. When the amount of gas increased inside the tubing, inside the well pore, then the average gradient will be much less. And this is the main concept of the gas lift. The main concept of the gas lift is I used just a certain volume, certain amount of gas, pre-designed, pre-calculated gas to inject inside the tubing. While injecting the gas inside the tubing is mixed with the fluid inside the tubing, then the total average of fluid gradient will be less than if I not used the gas. then the gas lift is a form of artificial lift, really is using in just to assemble, just to 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 some to help some wells already can be a flowing wells to be a gas lifted wells. It can be considered extension. A lot of people